In this video, the main user interface of OE Digital Manufacturing's application is explained. This is the first screen you see when you launch the application. The interface is divided into 4 tabs, each associated with different functions. Let's start with the NX Libraries tab. Here you can see the NX libraries that are used during simulations in the application. Actually, these libraries provide the manufacturing data required for the simulations. For example, in machining data section, you can see various cutting parameters associated with various cutting, part materials, tool materials, and cutting methods. These values are used automatically during the simulations in the application, and they should not be changed unless you are sure of their effects. Make sure that the customized libraries are successfully copied during the installation to ensure full functionality of the application and software. The next is the License tab. Here, click the refresh button to check the license required to run the application. Note that at least one free seat must be available in each license bundle. Also, here you can see which users are currently using the license. The third tab here is the Operations and Strategies tab. In this tab, the defined NX operations and machining strategies, which will be automatically used during the simulations, are shown. These strategies are created based on different sets of operations, feature types, and cutting parameters based on the Oxford engineering team's experiences. Here, you are enabled to edit each row by clicking the Edit button, delete it by clicking the Delete, and also you are enabled to add new rows to expand the table. But note that these changes must be saved before they can be used, which requires administrative permission to modify the system drive. In general, it is not recommended to change and modify this table unless you are sure about their effect on the process. The last but the most important tab is the Analysis tab. The tab is used to load a part and start the simulations. Once a model is loaded in step format to the application, an analysis card is automatically generated for that part. Then the user selects the part material and the machining option from the existing choices. Note that the material data here is directly linked with the uploaded NX libraries to the software. Then, if the selected machining type includes feature machining, the user can choose which type of features should be recognized and machined during the simulations. By enabling the Group Features option, features with identical geometries and machining directions are merged and combined into a single feature, which reduces the computation time during the simulations. Here, the interface also shows which available machines can accommodate the part based on its size. Then, when the user clicks to start the simulations, the analysis card turns into dark blue and the progress bar is started and displayed on the screen. Before the simulation begins, if an existing simulation is detected in the history of the simulations in the device, the software offers the option to reuse previously recognized and defeatured features for that part. Using this option can significantly reduce the computation time, and then everything starts.